So hello and welcome. Thank you for attending Android Summit. My name is Pete Varvarezis. It's the easier of the two names to use. I go by Pete. And this is CameraX, Portrait of an API. So just a little bit about me. I'm a distinguished engineer at Capital One. A lot of fancy words for manages code instead of people. Founder and co-organizer of GDG Wilmington. That's Wilmington, Delaware, not Wilmington, North Carolina. I'm also one of the Northeast mentors for the region. I'm an avid video gamer. Not that I'm really good at it, I just play a lot of video games. So in addition to my Twitter handle on there, you'll notice my PlayStation and gamer tag for PS4 and Xbox, as well as Battle.net. Find me on there, play some games, Destiny 2, World of Warcraft. I think Classic's coming out soon. Come join. So before we get into CameraX, who here's used camera in their app? Good, a lot of people, awesome. Well, regardless of why you're using the camera, paradigm to use is pretty straightforward. You add manifest declarations. You obviously need camera permissions. And then you'll want to tell the Play Store that you use the camera so that it can filter it out. If camera isn't fundamental to the usage of your app, make sure that you don't mark it as required by setting it to false. If you forget the false, it'll only be available on devices which have a camera, and specifically without any other sub permission or sub feature, I should say, such as back or autofocus. It'll ensure that it has a rear-facing camera. So if a device only has a front-facing camera, it won't be available through the Play Store. Then in your code, you'll need to detect which cameras are available. Then, of course, go and access the available camera. You'll create a preview class to hold the information that you're going to show the user while you build that preview layout to actually display it to said user. You'll set up listeners for capture so that you can then store that when it comes back, when the user taps on the screen or executes that, capture and save those files. And then when you're done, you'll release the camera. And I think the biggest thing that I've always run into has always been releasing the camera. So if you mess up anywhere along the way, the camera pretty much was unusable until you rebooted the device. It was not fun, and you would spend most of your nights doing this, sitting there crying because it crashed halfway through while you were trying to save a file because you forgot the file permission. So Android cameras is for, obviously, the history around this. It started with API 1. So it's been around because Android was designed for cameras initially before Google got a hold of the technology and they reevaluated the digital camera market. And they deprecated, thankfully, Camera 1 in API 21. It was a black box design. That is to say that you told it what you wanted, the camera did some magic and gave you that thing. If you said you wanted a preview, it gave you a preview. If you said you wanted a still image, it got you that still image. You didn't care how, it just gave it to you. And then, of course, as cameras evolved, as technology evolved, more properties were added. The ability to differentiate between a back and a front camera. In 4.2, HDR came out. And so they started to support some of these functionalities through scene modes and extensions that were built in there. The camera API also only provided compressed images at the time. And this all stemmed from the fact that camera hardware was a shared resource that was managed, and carefully managed, hopefully, by you. You had to make sure that you were, again, releasing it when you were done. And so it was a piece of hardware, and one person had it at a time, and that was it. And you lived with it, because that's what you did. You didn't care how it got done. You didn't have to look inside the box. But when burst mode came out, it became a bit harder to add that. It became a bit harder to find and set up newer features that were available. And so Camera 2 comes around. And it was added in API 21, or Android 5.0 or Lollipop for those. And it's the successor to the Camera API, which is great because it exposed the subsystem controls now. So instead of just saying, I want an image, you can get access to the stream of images that were coming through the system and analyze them in real time. This also provided things like better multi-camera support. It allowed Google and Android as an operating system to build and extend the functionality for the camera faster and expose that to the developers quicker. You also got better image intervals because it was running through the system. Sorry. You could directly apply your filters and effects as the images were coming through as well. So you could take and analyze images on the stream as it was capturing them. You also got better metadata because of the sensors and the other settings that were now exposed to you. And this came from a change in the way that the hardware was built, because they moved from seeing camera as a piece of hardware to being a device that was a pipeline instead. And it had multiple stages wherein you could inject and do things. And this allowed you to do those wonderful effects that you could do in real time. And we went from API 1, which was this wonderful little box diagram where you didn't know what was going on and you had a handful of requests you could make, to this wonderful design which had plenty of expandability, but became significantly more difficult to manage, but easier to upgrade and get powerful output out of. And so we went from something that was, give me something, to let me tweak this a little, but we still had some of the same problems that come with cameras. And that is, you still had to open, you still had to manage, you still had to release it. So all of the stuff got more complicated, and you still had to do the old things that were even more complicated than that. And so it didn't really solve the other problems that you had. And so finally, the reason why you're here, CameraX. I'm going to start. It is not the new Marvel superhero. It is actually a JetPack support library that simplifies the camera app development. And it does that while creating consistency across manufacturers. If you've written for cameras, like many of you have, you'll know that not every camera works the same way, and not every set of initialization vectors work for every camera. And so JetPack and CameraX are looking to simplify that and help you work across manufacturers with fewer lines of code. It's backwards compatible to Android 5.0. That's because it leverages the Camera 2 APIs that we just spoke about under the hood. And it does all of the stuff you would expect in that scenario. They have a use case-based approach. So very similar to the way Camera initially worked, where you said, I want a preview, I want a still image. These things are now the paradigm around CameraX, because you don't need to worry about all of the little minute details sometimes. And it helps abstract back Camera 1 functionality into the Camera 2 world. It's lifecycle aware, which is absolutely best part about this, because you don't need to worry when the lifecycle, it uses the lifecycle owner to determine whether or not it should release the camera. And this is obviously one of my biggest headaches. So the open and the release routines are now managed by CameraX for you. The extendable functionality, because Camera 2 has such a verbose API surface, it allows you to add additional functionality from the vendor side, as well as from as the OS upgrades. And this comes through in CameraX as well, with, again, some of the fun features and functionality and consistency you're expecting. And like most things at Google, it's currently in alpha. That is to say that the API surfaces may change in ways that are broken. They do recommend not using this in production, but it's so much fun. I'm going to recommend you not use it in production. I didn't say that. I didn't say that you should. I said don't. But it makes camera so much easier for everyone. And so those use cases I mentioned, there's preview, which obviously provides image for your viewfinder. There is image analysis, so the real-time buffer gets you access to run functionality such as ML-Kit or face detection or text detection. So ML-Kit integrates very nicely with this. And then, of course, image capture, which is the per-device optimization of high-quality pictures. That's what I wrote on there. So, and we'll go through each one of these, and we'll have code samples for that as well. So the preview use case. You start by creating a configuration object, which uses a wonderful builder pattern that exists out there that Google does for many of their more interesting APIs. Then you create the actual preview use case. This is Kotlin code for those who are unfamiliar. Just want to make sure. And then you set up your update listener to get that output, and then, of course, display it to user. Now, the output is typically, in this case, for a preview, some sort of surface view, a GL surface view, a texture view, surface view. All of this information comes back, and it pretty much just update that. You pretty much just update that view. The only difference here is that you have to transform it towards the device's orientation. So you'll get it, you'll always get it in a very in a fashion that may need to be altered so that it can be showed to the user based on how they're holding their device. So if it's in landscape, the portrait may look, the picture coming through the preview may look fine, but if you move it to portrait, it may not. And so you'll want to rotate the image that you're getting through the preview using a set transform function on the view itself. All of that code you'll find in the documentation and the references that I have at the end. And then, of course, to actually get it on the screen, to get it to start polling, you need to tell CameraX to bind to the lifecycle. Hopefully, whatever you're using is lifecycle owner. You can pass in a custom lifecycle if need be, but you pass it your lifecycle owner as well as the preview object, in this case, the preview use case, so that it can then start polling and handling, setting up the camera, getting the preview to the surfaces, and displaying it to the user. Now, I mentioned the builder. A builder has a handful of functions that you can set, including things like the handler, which lens you're using, whether you're using the front or the back camera, the aspect ratio that you want to target, as well as the target resolution and rotation. Now, you're not guaranteed these things. These are things that you'd like, and Google will, and Android underneath the surface here will try and provide those for you, but you should validate that you got what you expected every time that they call back with an image. The image will have the metadata of the actual resolution that it was taken at and the actual rotation that it's in. But these are the builder parameters and functions that you can call to set the state of the camera so that it can start obtaining those frames for you. And that's the preview config builder. And this is very common to most of the builders that you'll see for the use cases ahead. The next use case, of course, being image analysis. And again, very similar, image analysis builder, which you then send into a use case object. And then you set up a callback for the set analyzer function. In this case, you'll get the image plus the rotation in degrees. This makes it really nice because it's an Android, it's an image proxy, which is a proxy for an Android media image, which you can feed directly into a Firebase Vision image, and then get all of the fun things that you're looking for through Firebase, such as, again, face detection, text detection, image classifications, and of course, binding that to the lifecycle so that CameraX takes care of it for you, and you don't have to worry. The builder, again, very similar. The two new things here are the image queue depth, so you can have it hold on to a number of images so that you can analyze them. And there's also the image reader mode. So the reader mode determines whether or not you get the next image or you get the latest image. And the depth is the amount of images that it will hold for the next image. So it's possible if your processing takes too long that you may lose images that you can analyze. And so these things help you set up and schedule and analyze in a more efficient manner. And the third use case, image capture. For image capture, you start out the same way. You create your configuration object, you pass that into the use case, and then you bind to it. Now, that's where it's different. I didn't do anything with that image capture yet. I created something and I sent it into the camera, the CameraX API. How do I take a picture? Well, typically you're going to want your user to interact with the device to do that. So let's say there's a button somewhere that you have that when the user taps on it, that's when you want to take that picture. And that's exactly how that works. You do the image capture, take picture, and it will, the callback on that, the on image capture listener gets called with the image and the rotation. Again, very similar to what we saw with the image analysis. And this allows you to then save it to a file. And do whatever you want with that image capture that you're looking for, whether that's in memory, on device, if you're just showing it in a view, etc. Now, the builder here, again, many of the same things as the preview builder that we spoke about before. This one, you can set the flash mode so that the flash can obviously turn on when you're taking a picture. Sometimes you need the flash to help get a better picture. Me, I typically need a better person behind the camera when I take a picture. But that's the scenario I run into. And then, of course, the capture mode, which, again, part of the documentation eludes me at the moment. And then CameraX extensions. So I mentioned that it's extendable and that you can add on functionality. And this is vendor implemented functionality. So there's the extension library allows vendors to add functionality that would be available from their manufacturer camera so that all of us can use it. It is optional though. They have to opt in, they have to supply it in the firmware. It's up to them. These are those images and enhancements that you see happen all the time, things like, and that they can happen on a preview and on a capture. So you can pick and choose where they show up, how they show up in each scenario. And they're camera independent, so your front camera can support certain vendor specific CameraX extensions, and your back camera can support a different set or a similar set. And the list of extensions include auto, hope I get this one right, bokeh, that's how it's pronounced, bokeh. And that's basically portrait mode. It's called bokeh officially, but we call it portrait because we're human. HDR, which basically takes a bunch of pictures of different sets of exposures and picks an image that is a combination of the best of all of those. Beauty mode, which helps do facial contours and helps enhance facial features. And night mode, which lets you get really good images in low light. I've used night mode on a couple of cameras, and I saw things that in the image that I didn't see with my own eyes, so I thought that was amazing. Now, how do extensions work from a code perspective? The simple answer is similarly to everything else. You get your builder. With an extension, you then pass in the builder. In this case, for image capture, we start with an image capture builder. We take that builder and we pass it into the image capture extender. And if the extension is available, we can then enable it. If the vendor of the phone that you're on has chosen not to implement this, the defaults from the CameraX extension library kick into place. And the enable extension defaults to a no op anyway. So the availability check is simply so you can choose to show UI if you want, to let the users know that a certain mode or effect is taking place. I'm going to go back a page real quick, or two. So as of today, the Galaxy S10 series supports HDR Beauty and Night, and there are a handful of Huawei devices that support bokeh and HDR. Those can be found through the GitHub links mentioned in the references at the end. Back to the code. Once you have the extension added to the configuration, you then build the configuration object and pass it into the image capture use case, and everything else is pretty standard from there. You can bind multiple use cases, so you can do both capture and analysis simultaneously. You can do things that I thought weren't possible as well, and you can bind a capture with no preview or no analyzer, and it'll work. Apparently, the system, CameraX, is designed to, or will be designed to prevent use cases that don't make sense in combinations that are not valid or possible. So, and again, this is just HDR image capture. HDR preview, change the word image capture in the HDR image capture extender to be preview, and you get HDR preview. If you want a different effect, simply change the effect name. If we wanted from HDR to auto or HDR to bokeh, you can do that. And it all functions very similarly in that respect. Obviously, the availability of options that you can set are based on the type of effect that you're looking for. And so the quick summary that I have around CameraX would be API 21+, Android 5.0 or Lollipop. It's great because most of us love modern versions of Android here. And if you're targeting API 21 or Lollipop and newer, you'll have access to Camera 2, and this makes it significantly easier. It's still in alpha. They're on alpha 4 for the core. I think extensions are alpha 1, 01. They're all over the place, but you get easier camera integrations, and you get, because you let the life cycle control the open and release. You get consistency across devices. Let Google worry about all of those one-offs. Don't have to code them in your app, in every one of your apps, or in your libraries. Google can take care of that for you now. You get simple extension integrations. Let the manufacturer handle applying that HDR. Don't go through and look through characteristics and set scene modes and do all that weird stuff. I'm talking about taking portraits, but video. Can you do video? The answer to that is kinda. It's there, it's hidden. They restrict it to the library. I don't know anything other than it exists and they're preventing you from using it because it's not ready. When it will be ready is another question. It's not is it a new superhero? No, but it does give you superpowers when you want to use a camera. I can say personally, I was able to use CameraX and got an application up and running in less than 30 minutes using the camera. And I literally have a couple of checkboxes and display it to the screen. It made it so much easier, and you will occasionally get that the camera's unavailable because of how you might be debugging or testing, or because you actually wrote some bad code. But in comparison to the way that it used to be, CameraX makes it so much easier, so much nicer, and definitely is an improvement in the quality of life of developers. And that's what I have. So I'm going to open it up to questions. Thank you for your time. Here's all those links I mentioned. Feel free to take a picture, and we have mics on tables up front. If anyone has questions. So, thank you.
So admittedly, it's been a little while since I used the camera API. I think I used it prior to camera 2. And one of the hardest things across device was determining camera orientation, like when you're setting it on your view. Has that gotten any easier? Is there anything the CameraX API surfaces for like determining? I know some different devices had cameras mounted different ways within them, and so it was really hard to tell which way the preview should be displayed.
So for the preview, you can use the device orientation to rotate that surface view. But for every other use case, they provide that rotation in degrees to you. So you know which way to rotate it for storing it to a file, et cetera, or handing it into. So it tells you which way is up in the rotation parameter that comes back in that callback. Cool. But for preview, use the display on which the surface that you're going to display it on is currently oriented within. And again, I believe the CameraX documentation as well as the Camera 2 documentation both have the same transform code with some slight variance on variables and whether or not you use the device orientation or the default display or the display of the control that the widget is on.
Thank you.
Any other questions? Wow. Well then, enjoy lunch. I'm glad I could get you there early.